Okay, so good evening, everyone. So this is the quiz one questions for analytical geometry and calculus that we did recently. My idea today is to take you through the solution of all the questions, and so that it also kind of helps to prepare you for the end of semester exams as well. So basically, most of the questions were around circles, and then coordinate geometry. These were the main two areas that these questions are centered on. So I will go ahead and then present to you the solutions. So for instance, question one, in question one, you are asked to find the equation of a line. The equation of a line joining. In question one, you have to find the equation of a line joining this point, right? Equation of a line. Equation of a line. Equation of a line joining these 2 points A and B. So if you want to find the equation of a line joining 2 points, I usually must find the gradient. So you have point 1 here, then you have point 2 there, right? And then you have, so if you call this is point 1, then you call this as point 2, then you can find the gradient. So the gradient, you take B, right, which is usually the change in Y. So it's Y2, this is Y2, this is Y1, this is X1, this is X2. All right, so it's changing Y over changing to X. So we take Y2 minus Y1. So this is, you have Y2 minus Y1, and then you have X2 minus X1. So if you do that, then you have the gradient B minus 1 over A minus 2. And then, of course, if you want to find the equation of the line joining these 2 points, then after you find the gradient, all you have to do is to say Y minus Y. You can say Y1 is equal to M into brackets X times X1. And this is exactly what we have here, where we have Y minus Y1, Y1 is 1, and then M, and then X minus X1, which is 2. And in the second question, you say that if you have B now looking like this, so basically means A is 1, and then B is 3. Then, of course, you can easily compute the gradient of this equation. So the gradient is 3 minus 1, then 1 minus 2, which is minus 2. And you can go ahead to find the equation of the line. So fortunately, we have the formula here, or we have this formula, we have the equation of the line here. So if we substitute the gradient as minus 2, then we can expand it and write a finite solution as minus 2 of Y. So we have Y is equal to minus 2 of X plus 5. This becomes the equation of the line if you are given this choice of B. And the next one was to find that if you're given a circle of radius 5 and centered at the point 0 minus 6, then of course you can write the equation of the circle. The equation of the circle with center HK and radius R is given by X minus H. So this is the center. X minus H squared plus Y minus K squared is equal to R squared. So if you have that, then since this 0 minus 6 is the center, you can just substitute it in, and then you have x minus 0 squared plus y minus 6 squared is equal to 5 squared. So if you expand, then eventually you will get x squared plus y squared plus 12y minus 11. Then we have equation 4. Equation 4, we're giving the equation of a line. We're giving the equation of a line y minus 2x is equal to 2. And we are asked to find the x-intercept and then the y-intercept. So we know for x-intercept, y is 0, therefore y-intercept x is 0, right? So you take the equation, if you stop at x-intercept, y is 0, so this will give us, at x-intercept, y is 0, right? So this will give us 0 minus 2x is equal to 2, x is equal to minus 1. And then at y-intercept, x is 0, and you have y minus 2 of 0 is equal to 2, so y is 2. So at the x and y intercepts, you have values of minus 1 and 2. Then we have question 5. For question 5, we're given a circle. The equation of the circle was x minus 5 squared plus y minus plus 2 squared is equal to 5 squared, which passes through the point A. And then this means that the center of the circle, right, is 5 minus 2 and has a radius of 5. And then this means we have the center of the circle 5 minus 2 and then the points 7 and 2. If you look at this, then you can find the gradient. Here we said the gradient 5 minus 1. So you have your point A, so your center now, which is 5, 2. So you have an equation. The center here is 5 minus 2, right? And then you have a point. I have a point here, 7, 2. So we find the gradient. We find the gradient, and then this gradient is given by change in y and change in x, which is 2. And now we can write the equation, which is y minus y1 is equal to the gradient x minus x1, right? So if you take the point A here, which is 7, 2, then you can substitute this point into your equation of the line, which is y minus 2 is equal to 2, which is the gradient, into bracket x minus 7. This is going to expand to x, 2x minus 14. And in the end, you should be able to arrive at y is equal to 2x minus 12. Then we have question 6. Question 6 was to find the distance between 2 points, 2 minus 2 and minus 1 and x. Say that the distance between these 2 points, 2 minus 2 and minus 1 and x, is 5. So the question is, can we find x? So because it's the equation for the distance between 2 points, we know that now we are giving the distance between x and y, or between these 2 points, then we call it A and B, right? We call these 2 points A and B. The distance between A and B. So if we know the distance, then we can be able to find this x here. So basically the distance in between A and B, these 2 points, is 5 squared, and then we can use this formula here. It's 2 minus 1 squared plus minus 2 minus x squared. If you rationalize, if you solve for this, you get 3 squared plus 4 plus x squared plus 4x. And this is 13 plus 4x plus x squared. So now 5 squared is equal to 13 plus 4x plus x squared. So you can take x to the other side, and then you can take 5 squared to the other side, and then you get x squared plus 4x minus 12 is 0. And this will give you x is equal to 2 and minus 2. Seven. So question 7, we have the midpoint of the line segment joining the points A, right? You have to find the midpoint of A, which is minus 2 and 8, and B minus 6 and 4. So the midpoint, the midpoint, which is M, we call it, is equal to half, because we know that for the midpoint M, we have halfway on the x, the sum of x1, x2, and then y1 also plus y2. Right, as a formula for the midpoint. So you take your x values, you add them, and then you divide by 2. This is exactly what we've done. So half of the x component and half of the y component. And this is minus 4 and 2. Then question 8 was that what is the equation of a circle with center 1, 3 and line, and having a line 3x plus 4y plus 10 is 0 as a tangent, right? So exactly as we have done here, we have equation of we have a circle, then we have a tangent, we have a center. So we can find the distance between the center and the distance between the circle and from the center to the tangent. And this is given by this equation D, which is usually written as some D is equal to A x1 B y1 plus C over square root A squared plus B. So the distance where our A is from here, right? A x plus by plus C. And the point here, the center here is now our x1, y1. So we can make the substitution. D is equal to 3, which is the A, right? x1 is from the center, x, right, plus 4. So you substitute the A inside, 3x1 plus 4y1 plus 10 over square root of 3 squared plus 4 squared, right? So 3 squared plus 4 squared already will have. Now we can substitute in the x1 and the y1. So the x1 is 1, y1 is 3. We substitute it in, and then already at this stage, we can write here 9 plus 16. So if you do the algebraic computation, then you have 3 plus 12 plus 10 over square root of 25, which is absolute value of 25 over 5. Absolute value of 25 means plus or minus 25 over 5, so it is 5 plus or minus. If you have then this distance, then you know the distance as the radius, then you can write the equation of the line of the circle with the center 1, 3 as x minus 1 squared plus y minus 3 squared equal to the radius, which is 5 squared. And you can be able to resolve that and arrive at x squared plus y squared minus 2x minus 6y minus 15 is 0. And the next question was to find the equation of the tangent, right? Find the equation of the tangent to the circle x squared plus y squared minus 2x plus 4y minus 15 is 0 at a point 3 and 2. So the solution is you have a circle x squared plus y squared minus 2x plus 4y is 0. Then, so first you can find the first derivatives, right? You can differentiate. If you differentiate this, then you have 2x plus 2y dy dx minus 2 plus 4 dy dx. And then you can simplify and make dy dx a subject. If you do that, then you have 2 minus 2x into bracket 2y plus 4. I do think this is even 1 minus x over y plus 2. Right? Something like that. So at the point, right? At the point that we are looking for, at the point 3, 2, now we can find the gradient. So the gradient at 3, 2 now is given by minus 1 over 2. Now with that, you can write the equation of the tangent through the point 3, 2. So we have a point which is 3, 2, and we have the gradient which is minus half. You can write the equation of the line y minus 3 equal to minus half x minus 3. And if you expand everything algebraically, you arrive finally at 2y plus x minus 7 is equal to 0. Question 10. Question 10 was to find the distance between points 3, y, and 8, 7, which is 13. So we have to find y. So the distance between 3y and 8, 7 is 13. Then we can find y. So in that case, again, by using the formula of the distance, so if you have a distance between A and B, then squared, then this is x2 minus x1 squared plus y2 minus y1 squared. So now what we do is that you have 5 squared, you make your substitution, then you have the distance now is 13 squared, then you have 8 minus 3 squared plus 7 minus y squared. And then you can substitute and expand, so you have 5 squared plus 49 minus 14y plus y squared. You can put everything together and you have y squared minus 14y minus 95 is 0. You can make it y minus 19, y plus 5 is 0. And then you have y is equal to minus 5 and 19. Then question 11 was that if you have a line segment that connects x and 6, right, and 9 and y, which is bisected by the point 7 and y, 7 and 3, then we can find the point x and y. So basically, this question you can reframe it as 7 and 3. The point 7 and 3 is the midpoint of x and 6 and 9 and y. So if it is the midpoint, then you know that by midpoint formula, we said you have some x, y is equal to some x1 plus x2 over 2, y1 plus y2 over 2. So basically, if this is your xy, this is your x1, y1, right? So let me call this a1, and then this is your a2. Then you can write the sum of the x values, which is x and 9, and then 6 and y, which is the y values, over 2. So you know that 7 corresponds to the x component, 3 corresponds to the y component. So right, 7 is equal to half of x plus 9, and then 3 is equal to half of 6 plus y. So you can expand, and then finally, you should have x is 5 and y is 0. So again, in question 12, which follows, is a similar thing. It's a similar question, the same question now, just use the same idea. That minus 2 minus 4 is the midpoint of 6 minus 7, and x and y. And x and y. So you have minus 2 minus 4 is equal to half of the x component. So if I call this a1, call this a2. Then you have minus 2 minus 4 is half 6 plus y, 6 plus x, right? And then minus 7 plus y. So this corresponds to the x component. This corresponds to the y component. And then you finally have x and y to be minus 10 and minus 1. Of course, question 13 says that what is the equation of the line that passes through the points 2, 4, 4, 0? So you want the equation of the line that passes through this. First, you need a gradient. The gradient is a change in y, change in x. This is your a1, this is your a2. Then you say the change in y, which is 4 minus 0, and the change in x, which is 2 minus 1, is equal to minus 2. 2 minus 4 is equal to minus 2. And then your equation of the line is just y minus y1 is equal to mx minus x. And then this is given by y minus 4 is equal to minus 2x minus 2, which is minus 2x plus 4. So you can now derive an equation of the line that's y is equal to minus 2x plus 8. Then question 14, which had a preamble that if a line P divides AB, right? So you have a line, you have a point P that divides to the ratio 2:3, and find the point P, right? So we know this from the general formula for the arbitrary division of the line. So we said if we have an arbitrary division of the line, the ratio n to m, n is given by mx1, where this is maybe, as you say, this is 0.1, this is 0.2. So we say we have mx1 plus nx2 over n plus n, and then my1 plus ny2 over m plus n. So our n is 2, right? Our n is 2, our m is 3. So if we put it in, then we take the point x1, x2, and then y1, y2, and then we do the multiplication, and then we also divide by m plus n, which is 5. If you do that, then you should get p into bracket. You have 6 minus 6 over 5, and then here you have 15 over 5, and this gives you 0 and 3. And the next question says that does the point P, which we have found, which is 0, 3, lie on this line x, 5y plus 15 is 0. To find out if a point lies on a line, you just have to take the point and substitute it into the equation of the line, and you should get 0, right? So you have this point P, which is 0 and 3. You just have to take your equation of the line, which is x minus 5y plus 15. If you put everything into it, you should get 0 exactly to satisfy the equation of the line. And in this case, if we do, we get it to satisfy the equation of the line. It gives us 0 exactly. Then question 16 said, if you are given 2 points, A and B, and it is divided into a ratio 1 to n, question is, can we find the coordinates of this point? So we have a point, different color. So we have A and B, and it is divided into some n and 1. And we find this point, let me say R. Of course, it is asking us to find the x coordinate, but in general, can we find the point? And yes, again, we use the same formula. And here you see your ratio now. N is 1 and m is n, right? So n is 1 and m is n. Don't be confused, it's just representation. So now you have the point here, R, mx1 plus nx2 over m plus n, my1, ny2 over m plus n. We know m, right? M here is by n, so we can substitute it there. And then x1 is 2, so this is 1, it's 2, x1 is 2, and then we have n, right? N now is 1, and then we have 1 times point here 3, and then we do the same for the y part as well. So if you solve it, you have 2n plus 3 over n plus 1, and then for the y part, you have minus 2n plus 7 over n plus 1. That will give you that point. Of course, this is the x coordinates, right? And this is the y coordinates of that point. So basically, that's what this question was looking for. Question. The other question 17 spoke about if you have a circle and you have a line that goes through it, then the radius of the circle is greater than the line from the center to that touches the line at 90 degrees. And we said this is true. If this is true, then it means that circle has 2 distinct points, right? Then the line touches the circle at 2 distinct points. However, if it touches at only 1 point, then this means that the radius is equal to the distance the line makes from the center. And this means we have a tangent. And then for a tangent, it means we have only one solution, right? One solution, not 2. Of course, if the line is far away, if we have this and this guy here, and the radius is this guy, and the distance is here, right? This is the radius, this is the distance, and in this case, the radius is less than the distance. Right? You have, in this case, you have the radius is less than the distance, as the radius will be less than the distance in this case. Okay, so if the radius is less than the distance, then we say that there's no point of intersection, right? No point of intersection. Of course, this was part of the circles that we learned as well. Then the rest of the questions were based on the definition. And so I'll end here. And then after the quiz 2, I'll also do the same thing as well.